Hey everyone. So today we're going to be doing something called a box plot. Now this is another way to categorize and organize information that you get once you find your information. So let's see right here. First, let's say that we have these data points. So right here, let's do this. So let's say that we have the number of pets owned by a random sample of students at Park Middle School is shown below. Use the data to make a box plot. So if you've watched the last video, you know what a population is, you know how to get a sample, and you already know how to get your data and how to make it good data. So this is the second part now of how to organize and to analyze the data that you've gotten. So right now this will be a combined video for both 6th and 7th grade because you're both learning the same thing right now. So 7th grade will go a little bit more in depth, but 6th graders, you will need to know this for next year, so don't worry about if you know a little bit extra. So right now, a box plot is, we need to organize our data. So here we have the numbers, wait, why is it not changing? There we go. We have numbers 9, 2, 0, 4, 6, 3, 3, 2, and 5. Okay. So the purpose of a box plot is to make something called an inference. Now, an inference is an assumption, a guess, an educated guess based on the information that you're given. Now, if I know that these are the number of pets owned by students, one student owns 9 pets, some student owns 2 pets, some student owns no pets, this is my data sample and this is what I'm going to be working with. I'm going to try and make an assumption based off this data sample. Now, a box plot is one way to do it. And a box plot is mainly used to kind of tell where the distribution of the data is. So is it more towards more pets? Are people more towards less pets? Where's the middle of the road for pets? And I'll show you how that works. The first thing to do is you have to take your data and you have to put them in order from least to greatest. So I'm going to put that right here. Step 1, put from least to greatest. Okay, so we're going to do that here. So it looks like we got a 0, that's the smallest, and then we got a 2, then we got another 2, and then we get a 3, and then another 3, and then a 4, and then a 5, and then a 6, and then a 9. I believe that's all the numbers. Let's find out. So right now, let's line them up. So 1, 2, 3, 4. Yep. Same amount of numbers. Now it's just in order from least to greatest. Now the reason you have to do this is because you have to put this on a number line. So what I'm going to do here is I'm going to create my number line. Now here's the thing. In a box plot, every single thing in your box has a use. So this is what I mean by that. This number here will always be, the smallest number. This number here will always be the biggest number. So both of these sides will always be the biggest and smallest number. You're never going to have a side that's not being used. Okay, in this case, my smallest number is 0. This is why it's very important to put it from least to greatest, because I can just look at the left side. This is the smallest number, and 9 is the biggest number. So right here I have 0 and 9. Yeah? Next, I'm going to need to find something called the median. Okay? The median is the middle number, the very middle. So what I can do here is I can go there, there. I'm just trying to find out where the number in the middle is. So right here, 3. This number right here is my middle number. I have 4 on the right, 4 on the left. It is exactly in the center. So right here, my middle here is 3. Then this is what's called the median. And then we have to get the median on the left side, so we have to find the middle number. So I'll use green for this. So 1, 2, as you can see, there's an even amount, so the median kind of is in between these two 2's. Because there's nothing in between 2 and 2, the median is just 2. Now, let's say if those two numbers were like 3 and 4, and we had to find a number in between, that number would be 3.5. Okay, so you're always going to take the number in between those two. In this case, they're both 2, so you can just put 2. So that's where this goes. This is called the lower quartile. Okay, this is a lot of vocabulary, so please write these down. Please have a little sketch of this, because having this will really be helpful to organize your box plots. If you don't know these vocabs, you probably will have a very hard time making this. So there's a lower quartile. Next, you have to find your upper quartile. So that's on this side. We'll do that in blue. So we have the same issue here, blah, 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 blah. It's an even amount of numbers, so we have to find a number in the middle of here. So the number between 5 and 6 is 5.5, which means that the upper quartile goes right about there. If this is 3, so there's 4, 5, let's say this is 6, so there's 5, there's 6. It's going to hit at 5.5. Maybe I'll do those in a different color. Okay, so that's a 5.5. And then what we're going to do is we're going to connect, let me explain to you. This is the upper quartile. So we have a lower quartile and we have an upper quartile. All right, and then we're going to connect our quartiles. So I'll take my yellow here, and I'm just going to draw a line that connects my upper to my lower quartile. There we go. So this is my box plot. Without all these colors, it should look something like this. So I put these colors so you can see where everything is, but I'm going to show you what it looks like without all those colors and labels. So you still need to label this 0, you still need to label this 9, you still need to label this 3, you still need to label that 2, you still need to label this 5.5. And then you're going to draw a box, connect them, and this is what it should look like without all those colors and labels. It's just this. All right? Now you still need to know what everything represents. This is still the lower quartile, this is still the upper quartile, this is still the smallest number, this is still the biggest number, this is still the median. Now, why are you making this? What is this representing for you? Well, it tells me that because this is the median, this is the middle, right? This is the very middle of the data. That 50% of the data, half the data, is lower than 3. And the other half of the data is bigger than 3, up to 9. So if you look here, from here to here, that's half my data, right? Because it's split half and half. I'll put this one in purple. Half my data spans 1, 2, 3, 4 numbers, and the other half of the data spans 3, 4, 5, 6, 7, 8, 9. So if you really think about it, this graph is not evenly distributed, which tells you that there are more that have less than 3, right, than there are up here. Now let me try to explain that. there are only 4 numbers here, which means these numbers come up more often than here because these are all spread out, right? We have a 4, 5, 6, 7, 8, and 9. We barely see these numbers. There's a 4 there. Oh wait, actually that belongs on the other side. Yeah, there's a 4 there, there's a 5 there, and there's a 9 there, right? That's not a lot. That's not a lot of numbers that are bigger. However, look how many 2s there are. There's like 2 2s, there's like 2 3s, and there's a 0. There are more of these kinds of numbers. These numbers show up more often than here. Now, if you have more questions about that, I can explain that even further in office hours. But what this is supposed to show you is kind of how it's split. Remember, half of it only represents 4 numbers, and the other half represents 6 numbers. That means that these 4 are stronger than these 6. They show up more often than these 6. Yeah? If you think back to your proportions, if this 4 represents 50% and this 4 represents 50%, or not 4, sorry, this is a 6, represents 50%, that means that this 4 has more buying power than these 6. Because in order to get 50%, we only need 4 of these, whereas to get 50%, we needed 6 of these. So right now, it means that it's more likely in the class that they will have lower than 3 pets. That was a lot to take over. Watch this video again. If you really don't understand it, come to class. Statistics is one of the hardest lessons to understand. There's not a lot of math in it, but it's one of the hardest concepts to understand. So please don't feel bad if you don't understand this right away. I will explain this over and over again, and I'll try to show it in different ways. So don't worry too much. This is important because this is a type of information. As you can see, 6th and 7th, they're kind of having the same material. You'll be seeing this again and again and again, and it's only going to get harder. So please ask your questions now. So right here, if we were to, we already did this one. Here. A good measure for the most likely number of pets is, well, we already said that, right? A good measure is like less than 3, right? Because we just said that this half, this lower half, has a stronger ratio than this upper half. So the good measure for likely number of pets is definitely less than 3. That's going to be the first part. I can't write on this in this program, so you just know that this answer is right here. Next, 50% of the students have between blank and blank pets. All right. So if this represents 50% and that represents 50%, remember that this right here is also a median. It is the lower median, right? This is the lower quartile, which means of this 50%, I cut it in half again by this, right? And same here. Which means from here to here, this is 25%, this is 25%, this is 25%, and that's 25%, right? So 50% of the students have between blank and blank. This is where this box comes in. Use this. This is where this box comes in. This is 50%, right here. This is the middle 50. This is the center 50%. If you were to take the middle chunk of a class, that would represent this box. Because remember, this is 25. This is 25. So what's left is 50%, and that is represented by this middle box. So 50% of the students have between 0 and 3. 0 and 3 pets, because from here to here is 50. If this changed in numbers, let's say the middle 50% of the class owned between blank and blank pets. You're just going to take from this middle 50 and put it in here. So this would be a 2 and 5.5. Can we have 5.5 pets? No, we can't have half a pet, so we're going to put 6 instead. Lastly, almost every student in Parkview has at least blank pets. All right, this is the smallest number, 0, but it only shows up once. So almost everyone here has at least 2 pets because there's no 1, right? It's all more than 1, so at least 2. And that's how you use this information to kind of analyze and answer questions like these. Okay, I kept on using this graph. Next, proportions to make inferences. So this is a little bit more into 7th grade than it is to 6th grade, but this is still a really good review for 6th grade because you're going to be using something called the butterfly method, and you will need to practice this again. So right here it says, a shipment to a warehouse consists of 3,500 MP3 players. The manager chooses a random sample of 50 MP3 players and finds that 3 are defective. So right now let's write that out. Of the 50 that he tried, so 50 MP3s, he found out that 3 were defective, broken, not working. How many MP3 players in the shipment are likely to be defective? Well, we know that the shipment is 3,500. So 3,500 MP3 players. So we're going to make that match this side. We don't know how many are actually broken, but we can use our random sample to kind of predict it. So what we're going to do here is we're going to turn this into a fraction. So same as we did before. So 50 MP3s over 3 broken MP3s is equal to 3,500 MP3s over we don't know how many broken. So then we're going to do our butterfly to help us predict. And then we end up with 50 times x is equal to 3,500 times 3. So let's take a look at what that would equal. You see right here, 3,500 times 3 is 10,500 is equal to 50x. And then to solve for x, we divide by 50 to both sides. So x equals 210. So we can assume that 210 MP3s will be broken in the shipment based on our sample. Okay, so that's another way we can take our information and analyze it and make a prediction. All right. And lastly, we're going to go over this really quickly because I know that it wasn't really gone over and you might need a refresher course on how to take an average. So in an average, you just take, it's also called the mean. You're going to take all your numbers. So in this case, we have several numbers. We have 2, 3, 1, 1, 3. Okay, so step 1. In order to find the average. So these are steps to finding the average. Step 1, add all of the numbers together. Step 2, divide by the number of numbers. Now that's a little bit confusing, but what I mean by that is there are 1, 2, 3, 4, 5 numbers, so you're going to be dividing by 5. So step 1, add them all together. So we have 2 plus 3 plus 1 plus 1 plus 3. We're going to add them all together. That comes out to, let's see, that's 5, 6, 7, 10. 10 divided by how many numbers there are? There are 1, 2, 3, 4, 5 numbers. So divided by 5. So the average is 2. Average, you can put average or mean. They mean the same thing. So the mean is 2. Now here comes the next part. You need to know how to find something called, we already talked about the median. If you need another refresher on how to find a median, we can do that in class. But we need to go over something called MAD. Measure of, well, here it says measure of variability, but mean absolute deviation also works with this. Actually, that might be going too far ahead. So don't worry about that too much. Just right now, you need to know how to find your mean. You need to know how to find a median. You need to know how to make your box plots. And then you need to know how to interpret them. If you have any more questions, ask me on Thursday, and have a good day.